Good morning friends, welcome back to Panika Tutorials. In this video, I want to discuss one more numerical question related to highest response ratio next scheduling algorithm. These kind of questions will help you to understand the concept in a better way. So I request everyone to watch the complete video for better understanding. First let me read out the question, then I will discuss the solution with you. Look at the question. 5 processes such as P1, P2, P3, P4, P5 available with their arrival time and burst time. Calculate the average normalized turnaround time. Okay, we need to compute the average normalized turnaround time using preempt to highest response ratio next algorithm. Response ratio of a preempt to highest response ratio next is defined as the ratio of the time elapsed in the system by CPU time consumed by that process till that point of time. Also assume 0 by 0, which is undefined, as highest response ratio. They have given 4 options. We need to solve the question and find out what is the right answer. If you look at till now, we have discussed turnaround time. What is the way we will compute the turnaround time? Turnaround time is completion time minus arrival time. Once we got the turnaround time for all the process, we can easily compute the average turnaround time. But they are asking average normalized turnaround time. So now normalized turnaround time they have defined in the question, they have given, but due to space issue I have not written. Normalized turnaround time is turnaround time by burst time. Once you get the normalized turnaround time for each process, we can easily compute the average normalized turnaround time. Is it clear? Then in one of video, I have discussed about the highest response ratio next algorithm. In that one, we have discussed that mode is non-preemptive, but here they have given it as preemptive highest response ratio next. And then we will compute the response ratio of each process using the formula as W plus S by S, where W is the waiting time and S is the burst time. Is it clear? But here they have defined as response ratio of a preempt to highest response ratio next is defined as the ratio of time elapsed in the system by CPU time consumed by that process till that point of time. Is it clear? So with this introduction, let me solve this question for you. Okay. Now we need to draw the Gantt chart. Once we can draw the Gantt chart for the given question, we can easily solve the or compute the average normalized turnaround time. We know that always the Gantt chart will start from 0 units of time. Look at this one. We have a ready state and we have the running state. Totally we will have 7 states in a process state diagram. To explain the scheduling algorithm, we need 2 states such as ready and running. Okay, at 0 units of time, only process P1 is arrived to the ready state. Is it clear? As there is no competition, we can dispatch the process P1 to the running state. Okay, now when the next process will come at 2 units of time. So till 2 units of time, process P1 can perform its operations. Okay, is it clear for you? Now if process P1 has executed for 2 units, then its remaining burst time is 1 unit. Is it clear? Now at that time process P2 has arrived to the ready state. Okay, now you have a process P1 currently running in the running state and process P2 is in the ready state. As it is a preemptive, if it is a non-preemptive, we would have run the process P1 for 3 units of time. But they said it is a preemptive highest response ratio next. And how can we compute the response ratio? The response ratio will be computed as ratio of time elapsed in the system. Meaning is that we need to compute the response ratio of process P1 and response ratio of process P2. Is it clear? Now, how can we compute the response ratio? Ratio of time elapsed in the system. Now look at here. Now it is 2 units of time. When the process P1 came at 0 units of time, so 2 minus 0, which will be 2. Okay, are you able to understand how much time it has spent in the ready state? Meaning is that it is currently there. It came at 0 units of time and it is till now has elapsed in the system as for 2 units, because it came at 0 units of time. Now the time is 2 units, so 2 minus 0 is 2, and CPU time consumed by that process. Now look at here. Now 2 units it was running, so it is consumed the CPU time for 2 units of time, so which is 2 by 2, which is equal to 1. Okay, similarly we will compute the response ratio of P2. Now the current time is 2 units and process P2 has arrived at 2 units, so 2 minus 2, which is 0. So currently it was in the system for 0 units of time. And how much time CPU it has consumed? Till now, have we executed this process P2? No, process P2 was never entered into the running state, so it has not taken the CPU time. So it has taken 0 units of CPU time till now. Now 0 by 0, they said it is an undefined, has the highest response ratio. So coming to the 1 and 0 by 0, they have given the assumption that 0 by 0 is the highest. So process P2 has the highest response ratio as compared to the process P1. So we will do the context switching. Is it clear? So process P1 will go back to the running state and process P2 will be scheduled to the running state. Okay. Now how many units will run? Will run for 1 unit of time. Is it clear? So if we run for 1 unit of time, its remaining burst time is 2 units. Is it clear for you? By that time, process P3 has entered to the ready state. Is it clear? The arrival time of process P3 is 3 units. So process P1, process P3 are there in the ready state. Process P2 is there in the running state. Now we have to compute the response ratio of process P1, process P2 and process P3. Among them, which one will be the highest? We need to consider that process. Now response ratio of process P1 is, now the CPU time is currently, means it is 3 and process P1 has arrived at 0 units. So 3 minus 0 is 3. And how much CPU time it has consumed? It won't run for 2 units of time. So 3 by 2. Coming to the process P2, current time is 3 units. Process P2 has arrived at 2 units of time. So it was there 1 unit of time and it consumed CPU for 1 unit. Process P2 has run for 1 unit. So 1 by 1. Now look at the process P3. Current time is 3 and process P3 allowed at 3 units of time. So 3 minus 3 is 0. Is it clear? And how much CPU time it has consumed till now? 0. So it is 0 by 0. So looking at these three things, we can say that response ratio of process P3 is highest. So there will be a context switching. So process P3 will be dispatched to the running state and process P2 will go back to the ready state. So process P3 will run for 1 unit of time. Okay, is it clear? Are you able to understand? It will run for 1 unit of time and then again we will check the response ratio of process P1, process P2, process P3. Now let me compute the response ratio of process P1, which will be 4 minus 0 will be 4 by 2. Is it clear? I think by this time you know how I computed the numerator and denominator. And process P2 is 2 by 1. Process P3 is 1 by 1. Is it clear? Now the remaining burst time is 1. So among them, this is 2, this is also 2, this is 1. Now there is a tie. If there is a tie, we will look at the arrival time. Which process has arrived first? Process P1 has arrived first. So we will run the process P1 for 1 more unit of time. Meaning is that again there will be a context switching. Process P1 has the highest response ratio as compared to P2 P2 and P3. This will be P2. Is it clear? So process P1 will run for one more unit of time. So if it runs for one more unit of time, what is its remaining burst time? 0 units. Meaning is that process P1 has completed its task and gone to the terminated state. So process P1 is done. Is it clear? Now process P1 went to the running state. From running state it went to the terminated state. At 5 units of time, process P4 has entered to the ready state. So in the ready state, process P2, process P3 and process P4 are there. Now we will compute the response ratio of these three processes, and which one has highest, that we will schedule to the running state. So you have response ratio of P2, P3 and P4 we need to compute. How we will compute for the P2? Now that 5 units, it came at 2 units. So 5 minus 2 is 3 by CPU, it has utilized for 1 unit of time. Similarly, P3 is 2 by 1 and process P4 is 5 minus 5 is 0 by CPU time it consumed also 0 units. Till now the process P3, not P3, P4 has not entered to the running state. So it has not consumed the CPU time till now. So this is 0 by 0. So already they have consumed 0 by 0 as highest response ratio. So among process P2, P3, P4, process P4 has the highest response ratio. So process P4 will be scheduled to the running state. So process P4 will run for 1 unit of time. So its remaining burst time will be 3 units. Is it clear? Are you able to understand it or not? Now again we will compute the response ratio of P2, P3 and P4. Okay. What is the response ratio of P2? 6 minus 2 will be 4. Okay. And how many units of CPU time it has utilized? 1 unit. Is it clear? From 2 to 3 it has used the CPU time. And process P3 is 6 minus 3 is 3 by 1. Process P4 is 6 minus 5 is 1 by 1 because it has used the 1 unit of CPU time. So if you compute 4 by 1 is 4, 3 by 1 is 3, 1 by 1 is 1. Now which process has the highest response ratio? Process P2. So we will schedule the process P2 to the running state and process P4 will go back to the ready state. So process P2 will run for 1 more unit of time. Is it clear? So at 7 units of time, the process P5 has entered to the ready state. So we have 3 processes which are there in the ready state and 1 process is in the running state. So now we need to compute the response ratio of all the 4 processes. Okay. Response ratio of P2 will be how much? 7 minus 2 is 5, 5 by 2 because it has used the CPU for 2 units of time. So if it uses the CPU for 2 units of time, its remaining burst time will be 1 unit. Is it clear? And response ratio of P3 is equal to 7 minus 3 will be 4 by 1. Okay. P4 will be 7 minus 5 is 2. 2 by how many units of CPU time it has used? 1 unit only. Process P5 is 7 minus 7 is 0 and it has not used the CPU time till now, it will be 0. So already they have assumed here 0 by 0 is the highest one. So response ratio of process P5 is high. So process P5 will be scheduled to the running state and process P2 will go back to the ready state. So process P5 will run for 1 unit of time. So its remaining burst time will be 1 unit. Is it clear? Are you able to understand? Now we need to compute the response ratio of P2, P3, P4 and P5. So now let me compute the response ratio of P2. Okay, which will be 8 minus 2 will be 6. 6 by 2. Is it clear? Because it has used the CPU time for 2 units here and here. Okay, of P3 will be 8 minus 3 will be 5, and it used the CPU time only 1 unit, which is 5 by 1. And process P4 will be 8 minus 5 is 3 by 1. Okay, is it clear? Process P5 will be 8 minus 7 will be 1 by 1. So, if you compute the response ratio of P2 will be 3, P3 will be 5, P4 will be 3, P5 will be 1. So, which one is highest? P3. So, again there will be a context switching. So, process P3 will be scheduled to the running state and process P5 will go back to the ready state. So, process P3 will run for one more unit of time. Okay, so its remaining burst time will be 0. So after running for 1 unit of time, it will go to the terminated state. Okay, is it clear? Now you have process P2, P4 and P5 in the ready state. Which process you need to schedule to the running state will depend on the response ratio. So we will compute the response ratio of P2, P4 and P5. Let me compute the response ratio of P2. How we will compute the response ratio of P2? Current time is 2 and process P2 has entered at 2. So 9 minus 2 is 7. So it is there in the 7 units of time. Okay. And out of the 7 units of time, how many times it has used the CPU? Means how many units of time? CPU time consumed by that process. Okay, P2 here once and here once. So 2 units of time it has used the CPU. Okay, process P4, 9 minus 5 is 4 by 1. Okay, P5 is 9 minus 7 is 2 by 1, which will be 3.5, 4 and 2. So which one is highest? Process P4 response ratio is highest. So process P4 will be scheduled to the running state from the ready state. Okay, process P4 will run for 1 unit of time. Okay, and its remaining burst time will be 2 units. Is it clear? Now we will compute the response ratio of P5, P2 and P4. Okay, because it is preemptive. Okay, if it is non-preemptive, we no need to compute this much time. Okay, response ratio of P2. P2 will be 10 minus 2 will be 8 by 2. Is it clear? Are you able to understand? Because it has consumed 2 units of CPU time. And process P4 will be 10 minus 5 will be 5 and by 2. Okay, process P5 will be 10 minus 7 is 3 by 1. Okay, so which will be 4, 2.5, 3. So which one is highest? Response ratio of P2 is highest. So process P2 will be scheduled to the running state and process P4 will go back to the ready state. Okay, so process P2 will run for one more unit of time. Okay, then its remaining burst time will become 0. So process P2 after complete its task, it will go to the terminated state. Okay, so right now only 2 processes which are there in the ready state. Okay, so P5 and P4 we need to compute the response ratio. Now let me compute the response ratio of process P4. 11 minus 5 is 6 by 2. Okay, and process P5 is 11 minus 7 is 4 by 1. This will be 3 and this will be 4. So which one is highest? Process P5. So process P5 will be scheduled to the running state from the ready state. Okay, process P5 will run for 1 unit of time. Its remaining burst time will be 0, so it will go to the terminated state. Now, how many processes are there in the ready state? Only one process. So, that process will be dispatched to the running state. Okay, there is no computation, so we will no need to look at the response ratio. How many units of time it has to run again? 2 more units. So, process P4 will run for 2 units and it will go to the terminated state. Is it clear? Are you able to understand? At 14 units of time, all the 5 processes has completed their task. If you have a doubt, you can compute it. 3 plus 3 is 6, 6 plus 4 is 10, 10 plus 4 is 14. Yes, at 14 units, all the 5 processes completed the task. Now we need to compute the completion time of each process. By looking at the Gantt chart, we can easily compute the completion time of each process. P4 has completed at 14 units of time. Write that one. Then P5 has completed at 12 units of time. P2 has completed at 11 units of time. Then P3 has completed at 9 units of time. P1 has completed at 5 units of time. Is it clear? See, P1 completed at 5 units of time. After that, P1 never came. So, it went to the terminated state. Then P2 completed 11 units. Like that, we need to compute the completion time by looking at the Gantt chart. Once we compute the completion time, we can easily compute the turnaround time. Turnaround time is defined as completion time minus arrival time. Okay, let me erase this one so that I can use this space. Okay, so turnaround time is completion time minus arrival time. So 5 minus 0 is 5, 11 minus 2 is 9, 9 minus 3 is 6, okay, 14 minus 5 is 9, 12 minus 7 is 5. So we got the turnaround time. Now they are asking us to compute the normalized turnaround time. Already I have discussed in the starting of the video is normalized turnaround time is equal to turnaround time by burst time. So let me compute the normalized turnaround time. Okay, this will be how much? What? 5 by 3. Okay, are you able to understand? Turnaround time is 5 and burst time is 3, and turnaround time is 9 and burst time is 3, so 9 by 3, and this one is 6 by 2. Okay, this is 9 by 4 and this is 5 by 2. Okay, let me compute the exact values so that we can compute the average normalized turnaround time. Just now we have computed the normalized turnaround time. Let me compute the exact values. 5 by 3 is how much? 1.66, so on it will go. Is it clear? 9 by 3 is 3, 6 by 2 is 3, 9 by 4 is how much? How can we write 9? 4 2s are 8 and you have 1 by 4 which will be 2.25. Okay, 5 by 2 is 2.5. Is it clear? So we got the normalized turnaround time. Is it clear? Now we need to compute the average normalized turnaround time. Okay, average is nothing but sum of all these terms by number of process, which is 1.66 plus 3 plus 3 plus 2.25 plus 2.5, which will be equal to how much? You have 1.66 plus 6 plus 2.25 plus 2.5 will be 4.75. Okay, 4.75, this will be 6, 4.75, 1.66. Is it clear or not? So this is 11 and you have, this is how much? 14, and this is how much? 6 plus 4 is 10, 10 plus 2 is 12. Okay, so you got 12.41 by 5, which is how much? 5 2s are 10, and you have 2, so you will get 4, 0.4. Are you able to understand? 12 by 4 you can compute. 12 by 5 is how much? 12, 5 2s are 10, and you have 2 here. 2 by 5 is nothing but 4. Are you able to? 0.4. Okay, so this will be something. So it is approximately 2.4 something. So this is 2.34 is wrong. 2.84 is wrong. 3.67 is wrong. Option D 2.48. So this is correct. So the right answer for this question is option D. I hope you have understood how I solve this question. These kind of questions usually they will ask in competitive exam to test your knowledge. Is it clear? So this is little bit confusing question. I hope it is clear for you. If you still have any doubts related to this question or related to the concepts of whatever I have discussed in this video, feel free to ask me in the comment section. I will try to clear your doubts as early as possible. Thank you for watching the complete video. Have a nice day.